Well, I work at Siemens PLM Software and we design tools for automating engineering. And math is the foundation of all those tools. Geometry, physics, Boolean mathematics, statistics, they form really the basis of all the tools that we use to automate engineering and design. Frankly, when you sit down with one of our tools, you're touching equations that have been built for decades. And every movement you would make on the screen would touch and impact hundreds or thousands of equations. So we are very much a computer-based mathematics environment. And that's the way that all engineering and design and manufacturing are moving, both in the United States and around the world. So when you get trained as an engineer, or if you get trained as a designer, it's important to understand that the mathematics is there underneath what you're doing. It's important to understand a broader set of mathematics than most people are taught today. And frankly, I don't see any way that you can teach the breadth of mathematics that you need to understand what's really happening in engineering, design, and manufacturing without having computers to speed up the computation and the calculation, as the CBM folks have argued. The real space of domain in real practice in engineering and manufacturing and design is just much broader than you can teach in a normal curriculum. And what's more, the practice of engineering itself is much more complex than it was 5 decades ago or 100 decades ago. There are many more disciplines involved. The challenges you have to tackle as an engineer include the mathematical challenges, but also now include cultural challenges and social challenges. You have to anticipate or imagine the problems that your users will face when they use your product. You have to anticipate the problems that integrated products will have in talking to or working with your product. You have to anticipate the challenges of cultural adaptation. You have to anticipate challenges of communication. So an engineer has to have a profound foundation in mathematics, but also understand a much broader set of issues. So he has to know more math, and he has to know more of other things beyond math. And again, I don't see any way to do that unless we take advantage of some of the abstractions that are available through computer-based learning and computer-based mathematics. And many of the arguments that have been made here really tie to that. It also touches on the problem of multidisciplinary problem solving. Good engineering has to be multidisciplinary, and looking at a much broader range of problems than just how do you convert an equation into a new form, or how do you prove that a formula is valid. You got to tackle much broader problems than that. You need familiarity with that. And so the whole idea of a problem-driven approach to learning mathematics, I think, is very relevant for engineering as a whole, and will prepare people to use the kind of tools Siemens makes much more effectively. So, as I said, we're very much a computer-based mathematics company. We build computer-based mathematics. That's what we do. And we need people to be able to take the full advantage of that. And I think CBM is a great educational angle to make that possible.